This is a quiz about polynomial operations. We will be adding them, subtracting them, multiplying them, and factoring out the GCF. So let's get started. Simplify the expression below. For an addition problem, the parentheses really don't matter. So it's just a matter of combining like terms. I see we have a 4x and a 3x, and we have a plus 5 and a minus 2. If we combine the like terms, 4x and 3x make 7x. Positive 5 and negative 2 make positive 3. So 7x plus 3, and the answer is B. Problem number 2. You have to be more careful with a subtraction problem because this negative sign has to be distributed. I like to put a little 1 right here. So it's easy to understand if you imagine doing the distributive property with the negative 1. Negative 1 times x is negative x. Negative 1 times positive 8 is negative 8. The first set of parentheses has no negative in front of it. So this part will be unchanged. We will have 2x squared plus 4x minus 3. Now we can look for like terms. I see here we have an x term, and here's another x term. So those will be combined. And here we have a constant and another constant. The 2x squared in the front has no like term that goes with it, so we will just leave that unchanged. But positive 4, and this is like a negative 1, that makes positive 3 when you put them together. Negative 3 and negative 8 make negative 11. All right, so 2x squared plus 3x minus 11, that is A. Okay, problem number 3. We need to do the distributive property with this monomial in the front. So we need to multiply 5x to the 4th power times x to the 3rd power first. This x to the 3rd power, you can think of it as 1x to the 3rd power. When you do 5 times 1, that's just going to be 5. Then you have to do x to the 4th power times x to the 3rd power. When you multiply variables, you add the exponents. So you're going to end up with x to the 7th power. Then you need to multiply the 5x to the 4th power times 2x squared. Well, the 5 times 2 is 10. Now we're doing x to the 4th power times x squared, and that's going to be x to the 6th power. By the way, the reason why you add the exponents, let me just do this off to the side real quick. When I multiply, for example, x to the 4th power times x to the 3rd power, a common mistake is to think, oh, won't that be x to the 12th power? So the reason why it's not x to the 12th power is because you know that x to the 4th power means x times x times x times x, right? There's 4 x's. And then x to the 3rd power means x times x times x. If you put that all together, we have x times x times x times x times x times x. That's 7 x's, is my point. So that's why it is x to the 7th power and not x to the 12th power. That's why we add exponents when we multiply the variables. Anyway, the answer is right here, D. The answer is D. Okay. When you have a binomial times a binomial, you essentially have to do the distributive property twice. So for a brief moment, I want you to ignore the negative 2. In fact, to help you ignore that negative 2, I think I'm going to white it out. Okay, ignore this negative 2 for a minute. So do the distributive property with the 3x. So when I do 3x times 6x, well, the 3 times 6 is 18. And then x times x is x squared. Now I need to do 3x times 1. So of course that will just be 3x. Okay, so I distributed the 3x. Now I need to distribute the negative 2. So at this point, you're going to ignore the 3x. Forget about that guy. All right, so now you're just distributing the negative 2. So I'm going to take the negative 2. I think I'll do my little arcs down here. So negative 2 times 6x is going to be negative 12x. And then negative 2 times 1 is going to be negative 2. You can see right away that we have some like terms right here. So we will go ahead and put those together. So we will end up with 18x squared, positive 3x, and negative 12x. Together, that's negative 9x. And then we bring down the negative 2. So this is the answer, and so the answer is D. Okay, greatest common factor. So we need to look through this polynomial and look for the greatest number and the greatest variable that will divide evenly into every term. So let's start with the numerical part. 12, 8, and 24. What numbers will divide evenly into all of those? So for example, all of these are divisible by 2. So that is a candidate. Is there a bigger number that will divide into all of these? I think a good thing to do is start with the smallest number and ask yourself, what are all of the numbers that will divide evenly into the smallest number? So 2 goes into 8. What else goes into 8? 3, no, 4. 4 goes into 8. Okay, and then don't forget the number itself. 8 goes evenly into 8. Of course, the number 1 also goes into 8, but yeah, that doesn't really come into it. So, these are the 3 numbers that divide evenly into 8. Do they also divide evenly into 12 and 24? We've already established that 2 divides into everything. What about the number 4? 4 goes into 12 evenly. 4 goes into 24 evenly. What about the number 8? So far we can forget about the 2 because we want the greatest common factor. So we will not use the 2. So far the 4 is winning. What about 8? Well, 8 does not divide evenly into 12. All right, so that means 4 is the winner. So my GCF is going to include the number 4. So that's how you handle the numerical part. The variable part is easier. You look at each term and you go with the smallest amount of each variable. For example, with the x's, the first term has 2 x's. The second term has 1 x's. The third term has no x's. So the GCF will have no x's because that's the smallest amount of x's. How about the y? The first term has 1 y. The second term has 2 y's. And the third term has 3 y's. What's the smallest amount? Well, the first term had 1 y. So that was the smallest amount. So the GCF will have 1 y. So that means 4y is our GCF. So that comes out in the front of the parentheses. Now, we need to decide what goes inside the parentheses. And a good way to do that is by division. Take your GCF and you're going to divide each term by the GCF. So I'm going to divide everything by 4y. Okay, so 12 divided by 4 is 3. Okay, the x squared is unaffected by y, so that's going to just stay x squared. But then y divided by y, those are going to cancel each other out, so there'll be no y's here. Moving on to the second term. 8 divided by 4 is 2. All right, the x is not affected by y. Now, y squared divided by y is y. And just real quick, the reason why that is, okay, when I have y squared divided by y, what's really happening is y squared is y times y. So I have y times y divided by y. And then one of the y's cancels out. So that's why we just have a y left. Okay, another way that some people like to think about it is by subtraction. So when you divide variables, you can subtract the exponents. So if you think of this y as y to the 1 power, then 2 minus 1 is 1. So that gives you y to the 1 power, which is simply y. So some students are more comfortable thinking of it that way. Anyway, enough background information. So we have 24 divided by 4, that is 6. Now y to the 3rd power divided by y is going to be y squared. And again, you can either think of that as doing 3 minus 1, and that gives you y squared, or you can think of it as the y in the denominator cancels out one of the y's in the numerator, and then that leaves 2 y's left. Either way, this is the final answer. You know what? They only asked us for the GCF. Okay, so I didn't really read the directions. That was a good lesson for you, how to factor. So that was a good lesson for what we're about to do on problem number 6. But they didn't ask us to factor the polynomial, which is what I did. They just asked for the GCF. So when I found that 4y in the beginning, that was the answer. Okay, so the answer was D, because of the 4y. Okay, but I started to pause the video and go back and edit out all of that other explanation. But I'm going to leave it in because that was a good lesson preparing you for problem number 6. So if the polynomial below is factored using the GCF, what is the result? So now we're going to do what we did on problem number 5. Let's start by finding the GCF. So looking at the numerical part, the 10, the 15, and the 20, let's decide what number divides evenly into all 3 of these. Starting with the smallest number, which is 10. 10 is divisible by 2. 10 can be divided evenly by 5. And 10, of course, is divisible by 10 itself. Never forget the number itself. Does 2 go into 15? No. So that's out. So how about 5? 5 does go into 15. Does 5 go into 20? Yes. So far 5 is winning. Does 10 go into 15 evenly? No. So as far as the number part goes, 5 is the GCF. Okay, so let me put it a little bit lower. Okay, so numerically, the GCF is going to be 5. Except for one thing. If your leading coefficient is negative, like this one is, all right? If the number in the front has a negative sign, then your GCF is automatically going to include that negative sign. So the GCF is negative 5. Okay, so now let's lay down our parentheses and find out what goes inside. So as I showed you accidentally on the previous problem, we need to divide, oh wait, I forgot to talk about the variable part. Okay, so that's the numerical part. What about the variable part? We need to look for the smallest amount of variables from all of the terms. So the only variable is x. The first term has 4 of them. The second term has 3 of them. The third term has none. So the smallest amount is none. That's why the GCF will have no x's. Okay, so the GCF is -5, so we will figure out what goes inside the parentheses by dividing everything by -5. -10 divided by -5 is +2. And then the variable part is unchanged by this. +15 divided by -5 is -3. And the x to the third power just stays what it is. -20 divided by -5 is +4. Okay, so there it is. That is A. That's A. Okay, George correctly factored out the GCF of a polynomial, and this is his answer. What was the original question? Well, if you do the distributive property with your answer, it should give you the original question back again. So all we have to do is do the distributive property. So if we do 2x squared times 3x. First of all, 2 times 3 is 6. Now we're doing x squared times x to the third power. Remember, when you multiply variables, you add the exponents. So this will be x to the 5th power. And then 2x squared times 1 is just 2x squared. So this must be the original problem. All right, so 6x to the 5th power minus 2x squared, that's B. Problem number 8, which of these polynomials are prime? That means they cannot be factored at all. Circle all that apply. You might circle more than one. We have learned 2 ways of factoring polynomials so far. One of them is to factor out a common factor, a GCF. So if it's going to be prime, that means there's going to be no GCF. But we've also learned how to factor using the difference of squares. And that's where you take something, for example, if I had x squared minus 9, I could rewrite that as x plus 3 times x minus 3. All right, that's another way that we've learned to factor. So that we can't be having that either. So I'm just going to write none of this. All right, so neither of these things can be happening. It has to be unfactorable. The easiest thing to notice is a GCF. So let's start by eliminating all of the ones that are that have a GCF. For example, the first one, there's no number in common, but there is a variable in common. They both terms have x's. The smaller amount of x's is 1x. So this one has a GCF of x. So that means this one can be factored. So forget about that. In fact, you know what, just for practice, maybe the ones that can be factored, we'll just plain factor it. So the GCF is x, so I could pull out that x. And then if I divide everything by x, that's going to leave behind x plus 4. So that's how you would factor that. So we're not going to circle that one. I'm going to come back to this one. This one has no GCF. Okay, obviously there's no number that's common. But there's also no variables common to both terms. So this has no GCF. So maybe this is prime. This one, the 5x minus 5, has a GCF. You see both terms are divisible by 5. So that means 5 is a GCF. And if I divide each term by 5, I'm going to get x minus 1. So specifically, this is how you would factor this. The last one has no GCF. There are no numbers in common. There are no variables in common. Okay, so we've eliminated the two that have a GCF. Now, are either of these the difference of two squares? So far, other than factoring out the GCF, the difference of two squares is the only way that we have learned to factor a binomial. And when I say binomial, I'm talking about the fact that each of these have two terms. So are either of these the difference of two squares? Well, notice I'm saying the word difference, the difference of two squares. So for starters, to be factorable, it's going to have a negative in the middle. So that means this one over here is definitely not the difference of two squares. So this one will not be factorable. Okay, there was no GCF, so our only hope was difference of two squares. I shouldn't put an X through it. I'm supposed to circle all of the ones that are prime. So I'm going to circle this one. This one is prime. There's no GCF, and it's not the difference of two squares. You can tell because there's a big old plus sign right here. If this had been x squared minus 9, well, that's the example I did a minute ago. That would give you x plus 3x minus 3. Okay, but x squared plus 9 does not factor at all. Some students think that you can factor this by doing x plus 3 times x plus 3. But the reason why that doesn't work is because if I do the distributive property with the x, I'm going to get x squared plus 3x. If I do the distributive property with the 3, I'm going to get 3x plus 9. But then I have these like terms here. And these don't cancel out, they just combine. So that's going to give me x squared plus 6x plus 9. So this does not equal the original problem. So x plus 3 times x plus 3 is not another way of writing x squared plus 9. On the other hand, x to the fourth power minus 36 is the difference of two squares. Notice that 36 is a perfect square because that's 6 times 6. And we can factor this by doing, well, x to the fourth power is x squared times x squared. And then 36 is 6 times 6. This will work if we do plus 6 and minus 6. So all three of these are factorable except for the x squared plus 9. So that's the only one that should be circled. Okay, and just one more time, the reason why x squared plus 6 times x squared minus 6 works. Remember when I just showed you that multiplying x plus 3 times x plus 3, I showed you how that does not give you x squared plus 9 because you end up with 3 terms instead of 2. So I showed you why that does not work. Let me show you why this does work. Not that you asked, but just in case you're curious. If I do my distributive property, x squared times x squared, that is x to the fourth power. And then if I do x squared times negative 6, that's going to give me negative 6x squared. But here's where the magic happens. If I multiply by the positive 6 times x squared will give me positive 6x squared. And then positive 6 times negative 6 will give me negative 36. When I combine the like terms, though, something special happens. We have a negative 6 and then a positive 6. So these wind up canceling each other out. That's why this works, because the terms cancel each other out. And that leaves you with x to the fourth power, and then your minus 36. So this does give you the original problem back. So this works. That's why it's factorable. Okay, that was more than you needed to know. You're welcome.